Hello, my name is Tom Atwater, and in this section we will define the trigonometric functions and their fundamental identities. Then we will apply what we have learned by solving application problems. The 6 trigonometric functions of a given angle theta are defined in our first graphic using their customary abbreviations. Here we have angle theta in standard position. We have a point xy that lies on the terminal side of angle theta. And therefore, we know that if we draw this right triangle by dropping a perpendicular, we have the x value, the y value as the 2 legs of our right triangle. We're going to label the hypotenuse as r. And when we do that, it then leads us to define r in the following manner. Let xy be a point other than the origin on the terminal side of an angle theta in standard position. The distance from the point to the origin is given by r equals the square root of x squared plus y squared. Then the 6 trigonometric functions of theta are as follows. The sine of theta is equal to y over r. The cosine of theta is equal to x over r. The tangent of theta is equal to y over x, where x is not equal to 0. Then we have the cosecant of theta, which is r over y. And again, in this case, y does not equal 0. The secant of theta is r over x not equal to 0. And finally, cotangent of theta is equal to x over y, and again, y is not equal to theta. Let's use the 6 trigonometric functions to do an example where we find those values. Find the 6 trigonometric function values of the angle theta in standard position if the terminal side of theta is defined by the equation 2x plus y equals 0, where x is greater than or equal to 0. So to do this problem, let's draw a graph that represents that equation. We have the equation that 2x plus y equals 0. Well, that also means that y is equal to negative 2x. And if I can choose any point, of course, other than 0, 0, which would be at the origin, let me pick, for example, x equals 2. If x is equal to 2, that tells me y is equal to negative 4. So I would have the point on the terminal side of this angle theta as being 2, negative 4. Well, if that's the case, then I can draw a triangle by dropping this perpendicular, and I now know that this would be equal to 2, and that length would be equal to 4. The actual coordinate is negative 4, but the length of that side is 4. So that when I want to find r, I can use the Pythagorean theorem to say that the hypotenuse squared, r squared, is equal to 2 squared plus 4 squared. So r is the square root of 4 plus 16, which is the square root of 20, which gives me 2 square roots of 5. Well, now that I have my value of r, and I already had my values of x and y, I know that the ratio for sine theta is y over r. And so that's equal to y, negative 4, over r, which is 2 square roots of 5. Of course, I can reduce the 2 and the 4 down to 1 and 2. And if I wanted to rationalize the denominator, I would have to multiply top and bottom by the square root of 5. That will give me an answer then of negative 2 square roots of 5 over 5. Over 5. And that would be the sine of theta. Well, if we look at then the cosine of theta, cosine of theta is x over r, and x is 2, and r again was 2 square roots of 5. Those reduce down to 1 each. To rationalize it, I'd multiply again by the square root of 5 over the square root of 5, and that's going to give me an answer of the square root of 5 over 5. So that gives me my sine and cosine. Now let's find the tangent. The tangent of theta is equal to y over x. My y is negative 4, and my x is 2. So my tangent of theta is equal to negative 4 over 2, which is negative 2. Now I want to find the cosecant of theta. The cosecant of theta is equal to r over y. Interestingly enough, though, you should recognize that we calculated in cosecant theta, I forgot a c here. There, that's better. You should notice that the r over y is just the reciprocal of y over r, which means it's the reciprocal for sine theta. And the reason I point that out is that we will come back to that when we do some things called trigonometric identities. Well, r, remember, is 2 square roots of 5, and y is equal to negative 4. And therefore, the cosecant of theta is equal to negative the square root of 5 over 2. Secant theta. The secant of theta is equal to r over x. R, we said, was 2 square roots of 5. X is 2. Those reduce down to 1 each. And we get that the secant of theta is the square root of 5. And finally, the cotangent of theta is defined to be x over y. So that would be equal to 2 over negative 4, which is negative 1/2. And there we have the 6 trigonometric functions for that particular angle. Notice that the ratio for sine theta, which is y over r, and the ratio for cosecant theta, which is r over y, are reciprocal functions. Well, there are 6 reciprocal identities which allow us to find all 6 trigonometric function values when just one of the trigonometric values is known. Here are the reciprocal identities. Sine theta is equal to 1 over cosecant theta. Cosine theta is equal to 1 over secant theta. Tangent theta is equal to 1 over cotan theta. And then cosecant theta is equal to 1 over sine theta. Secant theta is equal to 1 over cosine theta. And cotangent theta is equal to 1 over tangent theta. Let's do an example where we use these reciprocal identities. Here we have, use the appropriate reciprocal identities to find the unknown function values. Rationalize the denominator if applicable. And we have the tangent of theta if we know that the cotan of theta is equal to negative square root of 5 over 3. So we want to find tangent of theta. We're given the cotangent of theta, and we know that the tangent is the reciprocal of cotangent. So tan theta equals 1 over cotan theta, which is 1 over, and then we were given the value that cotangent of theta is negative the square root of 5 over 3. So therefore, the tangent of theta will equal negative 3 over the square root of 5. Now we're asked to rationalize the denominator, so we need to multiply both top and bottom by the square root of 5. So our answer is negative 3 square roots of 5 over 5. All right. In the definition of the trigonometric functions, remember that r is the distance from the origin to the point x comma y. So r is a positive value. Now, if the point xy lies in quadrant 1, then of course x and y are both positive values as well. So all 6 trigonometric functions will have positive values in quadrant 1. What about the other quadrants? Here's a graphic that shows the relationship of the trigonometric sine values to the quadrants in which the angle theta's terminal side lies. So we have, of course, as I said, that in quadrant 1, all the functions are positive. Whereas in quadrant 2, we know that x is negative. Y, of course, will be positive. So therefore, any combination that involves x, which is negative, will create values that are negative. Well, the sine, which is y over r, and the cosecant, which is the reciprocal, will be positive in quadrant 2. The other 4 trig functions will be negative. Well, in quadrant 3, both x and y are negative, which means anything that involves x and r or y and r will also be negative. Anything that involves both x and y, a negative and a negative, would then be positive. Hence, tangent and its reciprocal cotangent are positive in the third quadrant. And finally, in quadrant 4, y is negative. So that means cosine and its reciprocal secant, which involve x and r, are the ones which are positive in the fourth quadrant. Using that grid, we can see how the signs of all the trigonometric values are derived. What I want to do next is an example in which we determine the quadrant or quadrants that an angle lies by evaluating the signs with the given conditions. So, identify the quadrant or quadrants for the angle satisfying the given conditions that sine theta is greater than 0 and cosine theta is less than 0. In this case, we know that the sine of theta is positive in quadrants 1 and 2. Cosine of theta is negative in quadrants 2 and 3. Therefore, only quadrant 2 satisfies both conditions. So the angle theta lies in quadrant 2. Now, in our study of trigonometric functions, you have noticed that r is the hypotenuse of a right triangle. And that being the case, neither x nor y could be larger than r. Given those ratios for sine theta, for example, which is y over r, we can determine the range for the function, in this case, sine theta. To do that, I want to draw a triangle with x, y, and r. So let me do that. We have a general triangle. This is my y, this is x, this is r, and this is theta. And if I deal with sine theta to start, that's y over r. And let's look at this. If theta is a very small angle, so something like this, we'll see that we have a ratio of y over r. It'll be positive, and it will be some fraction, a small fraction. But what happens as we let the terminal side of this angle theta come up like here? And this would be my angle theta. Well, what you'll see is the value of y, which is this side, compared to the value of r, what's happening is the value of y is getting closer and closer to the value of r. And in fact, when we get to an angle of 90 degrees, although we can't draw a triangle, you can at least imagine for the moment that the value of y actually equals r. And that's what happens. So again, we won't get a triangle there, but the ratio will be 1. And what you'll notice is, if I then create an angle with its terminal side in quadrant 2, here's r, here's my y value, you can see that what's happening again is that the ratio of y to r is getting less than 1. What I'm saying then is that the sine of theta is never bigger than the value of 1. And if you can take that same idea but bring it into quadrants 3 and 4, what you'll realize is that the sine of theta will never be less than -1. So all of the values, the range for the sine of theta, are between -1 and +1. Which is to say, for example, there is no such value of the angle theta so that you say sine theta is equal to 3. That just can't be because it's not in the range. Similarly, you can't have sine theta equals -2 because that would be out of the range. Okay, well, what about cosine theta? Well, cosine theta is equal to x over r. So this time we would be comparing the x value to r. Well, again, by the same reasoning that we did with y, we should realize that when we have an angle of 0 degrees, that would be where x actually equals r. In other words, the ratio would be +1. And then, as we let the angle theta extend up like this, the ratio of x to r becomes less than 1. And we keep going through the same phases that we did for y, and we'll see that once again, the cosine of theta is never going to be bigger than 1. And when I get over into quadrant 2, remember that the cosine is negative in quadrant 2, but the ratio of x to r is never going to be smaller than -1. In other words, the range for the cosine of theta is -1 up to +1. What about the tangent of theta? Well, the tangent of theta, remember, is y over x, and the values for y and x vary greatly based on the angle theta. And what happens is when we take those ratios, it turns out that we can get any real number for the value, for the value of the tangent of theta. Because when you take the ratios of x to y, not only will we get fractions, but we will also get mixed numbers. So the range for tangent of theta is the set of real numbers. Okay, well, what about the 3 reciprocal functions? That is to say, for example, the reciprocal of sine theta is cosecant theta. Well, let's look at sine theta. If sine theta has to be between -1 and +1, then its reciprocal, that is, in this case, cosecant theta, would have to be on this end greater than or equal to 1, and on this end, less than or equal to -1. That is to say, it'll never have a value in between -1 and 1 because it's the reciprocal of sine. So cosecant theta is greater than or equal to +1 or less than or equal to -1. Let me write that down. So cosecant theta is less than or equal to -1 or greater than or equal to +1. Now, by the same reasoning, let's look at secant theta, which is the reciprocal of cosine. You can see that once again, cosine needs to be between -1 and +1 inclusive, so the reciprocal has to be outside of that range. In other words, secant theta has the same range as cosecant theta. So secant theta is less than or equal to -1 or greater than or equal to +1. And finally, to finish it off, cotangent of theta is the reciprocal of tangent of theta, which means that it will be the set of real numbers. So cotan theta is, for the range, is the set of real numbers. All right. There are two other types of identities that are extremely important in the study of trigonometric functions. They are the Pythagorean identities and the quotient identities. Let's look at first the Pythagorean. We have that sine squared plus cosine squared theta is equal to 1. We have 1 plus tangent squared theta equals secant squared theta. And we have 1 plus cotangent squared theta is equal to cosecant squared theta. For the quotient identities, tan theta is equal to sine theta over cosine theta, and cotangent theta is equal to cosine theta over sine theta. Let's work an example where we use these identities to solve a problem. So we have, find all 6 trigonometric function values for the angle theta if tangent of theta is equal to -15 over 8, where theta lies in quadrant 2. Well, if angle theta lies in quadrant 2, then the sine and the cosecant function values are positive. All other function values are going to be negative. Since tangent theta is given, -15/8, use the Pythagorean identity, 1 plus tangent squared theta is equal to secant squared theta. And we know that tangent theta is -15/8. So we have 1 plus -15/8 squared is equal to secant squared of theta. -15 squared, of course, is going to become positive, so we have 1 plus 225 over 64 equals secant squared theta. We would have to change the 1 into 64 over 64. So that's going to give me, on top, 289 over 64 equals secant squared theta. Now, when we take the square root of each side, of course, we have the plus or minus square roots, except remember that we've already determined that this angle is in quadrant 2, and therefore sine and cosecant are positive. Everything else is negative, including secant. So secant theta will equal negative the square root of 289 over 64, which is then secant theta equals -17 over 8. Well, immediately, Since we have the secant theta is negative 17/8, we can use the reciprocal identity, and the reciprocal of secant is cosine. So cosine theta is negative 8 over 17. Now that we have the cosine theta, we can use another Pythagorean identity, which involves cosine theta and sine theta, to determine sine theta. So let's do that. We know that sine squared theta plus cosine squared theta is 1. Well, cosine theta, we know, is negative 8 over 17. So we plug that in, and we have sine squared theta plus negative 8/17 squared is equal to 1. So that means sine squared theta is equal to, is equal to 1 minus 64 over 289. So now we have to change the 1 into 289 over 289, and then subtract the 64 from the 289. So we get sine squared theta is equal to 225 over 289. Once again, we know that sine theta is going to be positive, so we only have to worry about the positive root of 225 over 289. That gives me an answer for sine theta equaling 15 over 17. Well, immediately, if we know sine theta is 15/17, we know that the cosecant theta is the reciprocal, or in other words, 17/15. And to finish it off, we just need to find cotan theta, which we remember we were given tan theta at the very beginning. So cotan theta is equal to the reciprocal, or in other words, negative 8/15. So we just found the 6 trigonometric functions using Pythagorean identities, reciprocal identities, from knowing just one of them. Well, now I would like for you to use the Pythagorean identities and the reciprocal identities to find the 6 trigonometric values in the next problem. Find all 6 trigonometric function values for angle theta if the tangent of theta is equal to the square root of 3 and theta is in quadrant 3. Pause the video while you work on this problem, and when you're finished, restart the video to check your solution. Since theta lies in quadrant 3, the tangent and its reciprocal cotangent will be positive, while all the other trig functions will be negative. So here we have tangent theta equals square root of 3. Well, the reciprocal cotangent would be 1 over the square root of 3. Rationalizing that denominator, we would get square root of 3 over 3. What about finding the secant of theta? Use one of the Pythagorean identities that says 1 plus tangent squared theta equals secant squared theta. And that means 1 plus the square root of 3 squared equals secant squared. Square root of 3 squared, of course, is just 3. So we have 1 plus 3, which is 4, equals secant squared theta, which means the square root of 4 equals secant theta. And again, in this particular case, we know that it's going to be negative. So we have negative 2 equals secant of theta. Well, Once we know that secant theta is -2, we know the cosine is its reciprocal, -1/2. To find the sine of theta, we can now use the Pythagorean identity that relates cosine squared and sine squared. So sine squared theta is equal to 1 minus cosine squared theta. And cosine theta is -1/2. So sine squared theta is 1 minus -1/2 squared. -1/2 squared is +1/4. 1 minus 1/4 is 3/4. So sine theta is negative the square root of 3/4. Well, negative the square root of 3/4, we can simplify the bottom. The square root of 4 is just 2. So the sine theta is negative square root of 3 over 2. Once we know sine theta, we know the cosecant is its reciprocal. So it's -2 over the square root of 3. Rationalize that denominator, and we get -2 square roots of 3 over 3. Let's look at an application problem. Suppose the uphill grade of a highway can be modeled by the line y equals 3/100 x in quadrant 1. A, find the grade of the hill. B, determine the grade resistance for a gravel truck weighing 25,000 pounds. To do this problem, let's draw a picture of this grade. We have a hill which has a y equals 0.03. In other words, 3/100 is the slope of this. So for every 3 feet that it goes up, it travels 100 feet horizontally. And this would be the truck, going up the hill. All right, so now, when we talk about the grade of the hill, the grade is the percent of that slope. In other words, it's 3/100, which of course we know is 0.03, which is 3%. So the grade of the hill is 3%. Well, what about determining the resistance of this truck? The truck is 25,000 pounds, and it's attempting, or it is going up a hill with a grade resistance of 3%. So what that gives us is a resistance using the formula that R equals W sine theta, where of course W is the weight, 25,000 pounds. Theta is the angle of the road, and R is my resistance. So we know that R is equal to 25,000 pounds times the sine of theta. Well, the sine of theta, this is a right triangle. And the sine of theta is going to be the opposite over the hypotenuse. Well, that means we have to find the hypotenuse, right? Because we have the side opposite, we have the side adjacent. So the hypotenuse, which I will label as R, little r, is equal to the square root of 100 squared plus 3 squared. That's equal to the square root of, 100 squared is 10,000 plus 3 squared is 9, so the square root of 10,000, 9. So sine theta then is 3 over the square root of 10,000, 9. So we have resistance equals 25,000 times 3 over the square root of 10,000, 9. When you work all of that out in your calculator, you'll find the resistance is equal to approximately 750 pounds. All right, great work in today's lesson. Now, remember, understanding trig functions and their identities is essential in the study of angles and the sides of triangles. The functions are tools used to solve problems involving lengths and angles. Be sure and work the exercises that your teacher assigns, and we'll see you next time.